Namaste, good morning, my friends. I'm again Ganesh Man Lama from Kathmandu, Nepal here, thinker, researcher, and concept designer. As promised, today also I'm going to discuss the topic of human power generation. How a human power can generate power mechanically, then we convert it into any power generation like electric, like mechanical, mill, factory, or whatever you want to do. You can make water pulling, water pumping, or any mechanical power for automotive equipments, cars, and household equipments too. So let's start this one. This is not an invention, my friends. This is a concept, a kind of alternative access, just an innovation, let's call it, a try for innovation. So I hope human power is a permanent power. I believe it. We can use it any place, any part of the world, at any time, at any condition, at any weather, no problem. So let's depend on it also, I think. Let's try it. I think we can do something out of it. So let's divert your mind towards it. Divert your mind toward it. Let's try it, okay? Let's begin. The topic is human power generation. First of all, here is the person. This will use a this is a hydraulic jack. Okay, we called it number one. Numerical will give you number again. By this, there is a, we call it two. There is a cylindrical jar, or we call it a cylinder. In this cylinder, we will fill hydraulic liquid, or you can use any other liquid also, no problem. Even water you can use, even soya oil, even mobile, even hydraulic, any liquid you can use it, no problem, because this is recyclable. I mean, you don't use it, you don't change its molecules. You won't have to change its condition, you won't have to change it or destroy it. It will make the power, produce power, and again come back to the cylinder. So, but here, the function is that before 2 days I have given you the gravity-less power generation by pressure. But this one is created by human being, the initial power, and this one is created power. How it creates power? See, now the point comes here. The hydraulic pump lifts by pressure, by human power pressure, lifts the water or liquid from this in this jar. But here there will be a, let's call 200 ton of weight. This is the weight. This is liquid and this is weight. Okay? This is the jar. Of the same distance from here to here. Okay. Suppose this cylinder contains the full phase from here to here. Total is called 1 meter height. One-meter height distance, this one. And it contains 3600 liter quantity. Okay? And here is also the same distance, 1 meter height here. And this one had the ability or the capacity of filling the same 3,600 liter capacity. So, here sorry, disturbing. Here, the hydraulic pump not supplies liquid here. There is a system here. The system is hydraulic piston is here. And the liquid flows from here. When pumping from here, the liquid goes to the cylinder and the piston is the 3,600 liter is filled here. Filled in this side first at the chamber A, and this is called chamber B. The chamber A is the refill one. When you pump this, pump this up, the refill one This is the flow, one-way flow. This is the one. When this, you pump this, hydraulic pump, the piston here, this is, let's call, this one is also piston, big piston. This is 200 ton of weight is here in this pump, in this piston only, in this weight. This goes up. This goes up. And this filled hydraulic liquid will be compressed here little, but here is one-way valve. One-way valve, okay? So when this piston goes up by hydraulic, that time the liquid reserved here, content here will flow downside in chamber B. The liquid from chamber A will flow to chamber B because there is only one-way valve here also. When it goes up, the one-way valve closes. One-way valve closes and the liquid from chamber A to go to chamber B. But when this goes at the top point here, top TDC, then we have to release the valve here. When you release the valve, the weight, this 200 ton of weight will come down. Due to gravity, it will come down. Okay, this will come down. That means the pressure of the 200 ton of this weight will press the hydraulic liquid in this chamber B, making high pressure. The capacity of 200 ton pressure will develop here. $200 ton weight pressure will be there. And then this liquid will have a high pressure. So here, we'll fix here hydraulic motor or hydraulic rotor, whatever you call it. Or you can use if you use water or any other liquid, then you can use turbine also, no problem here. Even turbine. No problem. But the exhaust, the discharge water or discharge liquid will be sent into the chamber A, back to the chamber A. And one thing, during this time, during this process of making power, that time, here will be also a kind of suction here. The suction also pulls water here back in this chamber, making power here also, developing power, admitting more power. So the discharge will be also easy to come here. And one thing, this is the process of making power generation by human being. For continuous power, what to do. This is just for 1 hour, 2 hour like this capacity, okay, power generation. But if you have to make a continuous power generation, you have to put this unit, several device like this, several unit like this. Or you have to make a bigger these chambers, cylinders, and more human powers. If you want to make it in kilowatts or watts, just watts, you can do it by yourself. Only single person is sufficient for 1 hour, 2 hour. But for megawatts generation, you need maybe hundreds of people, maybe thousands. We have to calculate. We have to check it. We have to do experiment. But this is a continuous power generation. You can manage it, no problem. But how to make it continuous? More power input, more unit, more power unit like this, or multiple you can call it. Okay, this is the concept. This is simple one. When this piston comes, this 200-ton power piston comes to this BDC, let's call it BDC. Then it stops, okay? Then human power is necessary to pull it again by hydraulic here. That time again this liquid will chamber A1, liquid will enter chamber B, and when the piston goes to TDC, then we have to release here the valve. The 200-ton weight will fall down again slowly, and the discharge will start. The power generation will also start. This is number one. Okay. Another process is we can make another pump here. No need of this upper part. No need. This one, no need. Upper part, no need in this one. Because we will pump the liquid by same size here. Same size cylinder. We will pump from down and the liquid goes up to here, the chamber. From here. This one is number 2, we call it second option. Second option we can call it. Then what this will do? The pump will pump the liquid at the same ratio. At the same ratio to the chamber here. But the speed of this lifting will be very slow. Even 0.5 cm per one lift per one lift of height. Maybe we can call it, if this is 1 meter height, then only 0.5 cm could be lifted by this hydraulic, this pump. But the liquid will be filled 0.5 cm. The quantity of the liquid will be high in this one, refilling here at the same time. But this one we leave the hydraulic from here. That is the difference. I hope you understand, try to understand yourself. By here, this pump will leave very little height, but more quantity it will supply here. But this pump, the upper one pump with a hydraulic jack, it will pump little liquid like lifting, like this same lifting process, little by little, little by little, little by little, but it will have little faster. Okay, less quantity. This one has less quantity but higher height. This one lower height but more supply. But this one has higher height but little less supply. That is the difference of this pump and this pump. Which type of pump you want, you can use it. If you want to let the water, let the liquid very fast to a higher height, then you have to use this one. But if you want little height but more input, then you can use this pump. That is the difference. For example, 0.5 cm height, for example, 0.5 cm height, let's say year 1000 liter. Example, this is for only example. It will have a big diameter displaced area cylinder, but more liquid. Okay, it will put input here more liquid. But for higher height, let's say 1 cm high, then the size of the cylinder will be 50%, but the height will go 1 cm high. This is the difference. If you go wider, you will have more input but less height. But if you have a small size, a small diameter cylinder, then it will go upper height. At the same ratio, you pump. Same pump, the difference will be this. Main difference. So, if you want the liquid to drop from a higher height, like in hydrogeneration, then the second one pump, this one, the first one is very useful because this will send the liquid to a higher height but in less quantity. So it will, and after you will use it accordingly. By governor, by full flow, whatever time you like, whatever power you like, that time you can use it. But here, this one should have a constant power and constant flow and constant generation, constant discharge, and constant consumption. So, my friend, I hope you understand this, my concept, and I think is very useful for underdeveloped countries, underdeveloped people who are surviving in poor countries, poor areas. So let's try it. I don't say it's 100% useful for human being, but I'm sure it will help. It will bring a consideration. It will bring a support to the human being in different sectors, because big hydropower, mega hydropower, mega uranium project, if bomb drops over there, if America drops bomb over there, if Russia drops bomb here over there, if China or any country, any powerful countries drop bomb, or even there is fight, even there is natural destruction, what you will do? Everybody will be in trouble. Everybody will be in trouble, No light, no energy. What you will do? You will die. So, depend on yourself. Depend on nature, my friend. That's all. Namaskar.